Training lead code solution. If you want the best mock interview experience in North America, feel free to check us out at baozitraining.org. We're here to help you land your next big offer. And also, I have a friend who also has a YouTube channel. He's a very smart guy. He's like ACM finalist, and he's doing competitive programming and is also doing the lead code solution. So lead code live with Larry. So he's literally solving all the lead code questions live. I don't know if he prepared beforehand or not, but if you check his videos, it's pretty fun. He's a very smart guy, and also you guys should follow his Instagram as well. Did he list it here? He's a world traveler, has a lot of fun traveling around the world. Anyways, so today we're going to talk about, well, not a lead code question, but a Google Kickstart 2020 round A plate solution. So just in case you don't know, this made me a little bit of nostalgic kind of feeling. Lead code is kind of a new thing, right? Started in 2011 and then really catch up in like maybe 2015, 2014, something like that. But before that, when people trying to compete or solving those questions, is mostly competitive programming, ACM, ICPC type of thing. And at that time, I was basically 15 years ago, I was still in China. So my school has this thing called ZOJ Online. It's from Zhejiang University in China. We're actually one of the schools that doing really well on this. Peking University, I think, is number one. But anyways, if you want to practice the moment you started solving lots of lead code questions, you might get bored, you might get a little bit frustrated, or you might want more challenge. If you want more challenge, there's a Google Code Jam, there's Google Kickstart, there's also a thing called Google Hashtag. It's like they are literally like all very similar things, like all belong to Google. So here is a Google Code Jam. If you change the URL just to hashtag, you can see the website actually looks exactly the same. Hey, okay, maybe not. Let me try Code Start, Kickstart. Okay, Kickstart is the same. So why hashtag? Hash code, not hashtag. Google hash code. See, those three are the same. There's also a thing called Top Coder for old timers to practice, and there's also Euler project. Anyways, so for those kind of questions, the only difference between for those questions from lead code is you have to deal with input and output, but the problems I think is relatively similar, and sometimes it's more challenging, it's more fun. So feel free to also take a look with those competitions. It will increase your interest, also give you that stress level that, oh, you're competing with others, right? Okay, so let's look at the problem. So I got the link here. So Google did a great job that for all those kind of questions, they also have a very good analysis. You can literally just check the analysis. So the problem here, simply put, is I'll just directly jump here. So this two means there's two test cases. So give you array, two arrays, basically it's a two-dimensional array that has two rows, and each row has 4 columns. So each one of them represents a score, and 5 is basically you want to choose 5 elements from these two arrays. Each array has 4 elements that sum is the maximal, and then you cannot randomly pick. Once you pick element, you have to pick all the elements before this. So they can put any kind of imaginary stories. This is something I remember when they first trying to think about the problem. It's the fun part, but essentially it all boils down to a math problem. So now basically you have to give the maximum number of this, and they have very strict output. There's a few ways when I first look at the problem, I'll think about it. So first thought is very similar to merge multiple lists. This is a kind of like a medium question in lead code, remember? Giving you a multiple, okay, I can draw something here, I guess. It's like simple questions, so giving you a multiple list. So this list is 1, 2, 3, 1, something like that. Normally it's sorted, so, and then you can have a pointer and then keep merging those lists. So this is a merge list idea. This won't work because you can't really sort the arrays, because the problem requires once you have this item, you have to have all the previous items. So you cannot sort, won't work. Second sort is. Second, this should be a thought. My bad. So second thought is keep a maximal heap. So what I'm trying to do is, so okay, sure, I can now sort the array, but if I keep a maximal heap here, so I always look at the largest value from all of those lists. Would that work? No, the method is wrong, because so given the example, the greedy algorithm won't work, because here giving you two arrays, each array has 5 elements, and then you want to pick the 3 plates. So given that algorithm, you would pick 2, 2, 2, because 2 is always larger than 1. However, 1 has a lot of 100 afterwards, right? So the actual solution is 1, 1, 100. So silly idea, won't work. So now the third thought seems to basically we have to brute force. So for all the different combos of P, we check what's the maximal value. So this is basically what I quote from the analysis is a exponential solution. Because what we're gonna do is literally we have to pick all of the P elements, have all different of combos of those P elements from these arrays, and then we have to compare one by one. So essentially you can think about this way. So there's a K elements. So here there's n rows here, and then there's a K columns, and then you want to pick P elements. So essentially you have every time you have a K options to pick, and then how many you have to pick? You have to pick kind of up to n times. So you have to K times K times K, and times n times of K. So this basically give you a K times K to the power of n, kind of a worst case solution. Why? Let me see. Why is a K to the times of n solution? Because yeah, you have to every time you have to pick elements here, and then you have to iterate through all the different combos. So you cannot just pick up to P. Okay, so basically this is a competitive programming problem. At this moment, it should be very obvious that you have to go with a DP solution, because you can sort the array, and then it's only asking for a yes or no question, or a maximal or minimal extreme value question. So this should be dynamic programming. So as we know, this is a little bit tricky dynamic programming. As we know, first of all, we have to define what the formula is. So we're going to define this formula. So let's say dpij denotes the maximal sum that can be obtained using the first I stacks, where we need to pick j plates in total. So essentially, if we allocated a two-dimensional array here, so we're gonna need a number of n rows, and then here we're gonna have p columns. You might think, why not k problems? That's the thing, because you might not need to go through pick all the k, but you do have to pick all the p plates, right? So that's why this makes more sense. And so whenever you have an array here, that means until this row, so you can only pick from the row including the self and above. And if you gonna pick p plates at this moment, so p means if this is a 1, 2, this is a 3, so you pick two plates. This is so far the global maximal till this moment. Here means you can only pick from these 2 rows, and then you pick 3 plates. What's the maximal? So basically this part will be your last maximal, because you go through all the n rows, and then this is your p number of plates. So normally when we do dynamic programming, we allocate the array a little bit larger, so that we can have the initial values under the 0 column and 0 row. So that was easy. So now basically this is the pseudocode. So essentially what we're gonna do is, so we're gonna populate this array. But how do we populate this array? For each of the values, so the formula looks like, so here it's either itself, but actually there's another for loop here. So the general idea is, whenever I'm here, right? So what's my minimal value? My minimal value is, so let's assume I'm not picking any elements from this row. So that's essentially all the elements to this row. And because I can pick X number of items here. So here is only one, but assuming there's actually multiple ones. So it's this formula here. So we're gonna have a rolling sum to keep a sum of. So for each of the row, you have a rolling sum. So if this is basically, we understand what rolling sum is, right? So this is the value, and then this is the value itself, including the previous cell. This is the value is itself, including the previous cell. And then what we're gonna do is we'll have a rolling. The maximal value of here is itself, or if I pick less item from this row, that means I will pick more item from this row. So, but I can only pick from the top. So I pick item here, so I less than item here. I pick another item here, I minus one item from here. So essentially is, if I pick item from 2 here, I want the 2 sum of here and the previous value. So this is basically, till that moment, this is the global maximal value. So plus this sum here. But I have to do a for loop because it could be I only pick 1 or 2 or 3. I have to enumerate all the different solutions. That's why we have to have another for loop, have the minimum value of j or k because you are bounded by k, and you're going to compare to yourself. So this is basically, during this for loop, this is the maximal value, right? So you're going to keep doing this. You're going to increase the sum, like I said. So essentially you're going from here, second row, increasing the sum, but then you're decreasing on the first row. So decreasing on the not first row, previous row. This is I. So once you have this idea, so it should be relatively simple. It's a time complexity. It's n times p times k. So way to code it up is, this is basically handling the input, and then we're gonna have the array nkp. So have the prefix sum. So this could be using one-dimensional array, but just for this problem, I just have the prefix sum, and then have the lookup, which is n plus 1 and p plus 1. And then we just pretty much keep filling the value. So I'll show it up here. We're just doing this. This is exactly the formula. So this is the maximal, and then we're doing the maximal of itself plus the prefix sum, increasing this x, but keep decreasing the previous row. And then we'll have the values here. Okay, so that's about it. And if you're interested, you can actually download the ZOJ GitHub. So it has the values. I was looking at it. It's actually giving me this nostalgic feelings. So this guy, Old Big. So if you know Old Big, it means 老大 in Chinese. It means big bro. Guy is very solid. See, this is back in 2008. They rewrote the entire ZOJ, I believe, using Java, J2EE, all these Java beans, JSP as front end. Yeah. Anyways, okay. If you have any questions, feel free to leave any comments below. It's a little bit tricky DP, but it's relatively straightforward as well. All right. See you guys next time.